Okay. Today is January 29th. Okay. All right, function operations. So today we are learning about function operations, which is when we add, subtract, multiply, and divide. So that's what we're doing today. We are adding, subtracting, multiplying, and dividing functions. And adding in what we did yesterday, which was function notation. So it's sort of the combination of things. We are also going to talk a little bit about domain. And so what value is x not allowed to be? Right here, what is x not allowed to be? X cannot be 4. Ladies and gentlemen, that is domain. We've been building up to that for the entire year so far. And you can look at that and say, I can't plug in a 4 there. But why? Why are we not allowed to plug in 4? Because we're not allowed to divide by 0. Denominators are not allowed to be 0. And that's why. Okay? What do we have to do on number 2? Factor. Very good. Factor first is always a good option. So I'm going to try and factor the denominator. X times x is x squared. Last times last has to be negative 18. What times what is negative 18? I'm sorry? The last I heard that building 1 and 3 Yes, I'm sure. All right. What times what is negative 18? 6 and negative 3. Positive 6 and negative 3. There we go. All right. So, what values are x not allowed to be? 3 and negative 6. Very good. So we've been building up for basically this whole year. I've asked this question a number of times. And domain can be a very tricky concept for a lot of students. So for us, what I believe my job is for you to remember is that the denominator gives us information about domain. And that's really what I need you to worry about right now. If there are numbers that we need to exclude from our domain, then they come from the denominator. So what this means is x is not allowed to be 3, x is not allowed to be negative 6, but all the other x values work just fine. X can be 1, x can be 0, x can be negative 12. Okay, all the other x's work, but these ones do not. We can also see that graphically, which we'll do in a little bit. So first, function notation. These are the operations. You need to write this down. I'm going to give you a minute to do that. This is notation. Write it down. I'm going to. Okay. So here on the last one, this is f divided by g in terms of x, which just means f of x over g of x. These division problems turn out to be the easiest most of the time. This part where it's saying g of x cannot equal 0, that's the denominator. Denominators are never allowed to equal 0, and that's telling us information about domain. Okay? So denominator domain, we're going to look at that here. All right, this is all notation. And we want to be very careful when we use this notation, so that's what we're paying attention. We will need parentheses to help us out. So example 1, I'll flip back to it later. Example 1, perform the indicated operation, state the domain. Perform the indicated operation. State the domain. Perform the indicated operation. State the domain. We have f of x equals 4x squared minus 9. And we have g of x equals 5x squared plus 3. So you have to get used to two different kinds of notation. You're going to be presented with both, so I will do the same in notes. So here's our first problem that we're going to do. It says f of x plus g of x. And I want to figure out what that is. This is function notation. It says f of x. What can I replace f of x with? 4x squared minus 9. These two things are equivalent. So really what we're doing is we're saying I can put in f of x. I can substitute in this big giant thing. 4x squared minus 9 in place of f of x. Then we are going to add g of x. What can I put in place of g of x? Yeah, 5x squared plus 3. Pretty easy there. So we have f of x plus g in terms of x. All right, and then it's just a matter of combining like terms. So 4x squared plus 5x squared is 9x squared. And negative 9 and a positive 3 gives me negative 6. Ladies and gentlemen, this is your answer in terms of x. We have a term with x in it, and that's what this notation means. We're adding f and g together, but they're both in terms of x. So we get x's in our answer. Does that make sense to you? Okay. We want to talk about domain. So this is a really good warm-up for domain because we're going to start this in the next unit. And domain, when in doubt, graph it out. So what we're going to do is we're going to graph this function. So you're going to just plug it into your graphing menu. 9x squared minus 6. You're going to graph it. And it's what shape? A parabola. Yeah, it's a parabola because it's x squared. When we talk about domain, this is a D for domain. When we talk about domain, we can look at the graph and we simply get to ask ourselves, domain refers to the x values that we're allowed to use. What x's can we use? That means the x-axis. Our x-axis goes left and right, and so we want to ask ourselves, well, how far to the left does this parabola go? How far to the right does the parabola go? So our parabola is growing upwards, but it's also getting wider and wider and wider, isn't it? So how far to the left does this parabola get? Forever. It goes forever to the left. That would be negative infinity. How far to the right does this parabola go? Forever. Right? It's growing up, but it's also getting wider and wider and wider and wider. Forever. All the way to the right to infinity. We put a comma between these and parentheses around it. This is called interval notation. It's the shorthand for domain. So I want you to see that. And that's domain. We can look at the graph and see domain very often. Okay? We'll talk more about that. All right, next, letter B. We have f of x minus g of x. This is one where you need to be very, very careful. What can I replace f of x with? What is f of x the same as? 4x squared minus 9. Now, subtraction is a problem because we have to subtract everything. So we're subtracting the entire g of x function. What can I replace g of x with? What is g of x the same as? 5x squared plus 3, yeah. This is the most common mistake. What are people not going to do? Distribute the negative. That's where the mistake happens. We need to distribute our negative because we have to subtract all of the terms. So I'm going to go ahead and do that. 4x squared minus 9. What's negative 1 times 5x squared? Negative 5x squared. What is negative 1 times 3? Negative 3. And then again, we just get to combine like terms. So we have 4x squared minus 5x squared, which is negative 1x squared. We have a negative 9 and a negative 3, which is negative 12. This is our answer in terms of x. There's the term with the x in it. So in terms of x. All right, let's think about domain for this one. Again, I want to think about the graph of it. What shape is this function? Parabola. Again, it's also an x squared function, so it has the same shape, but it has a negative in front. What happens to our parabola when there's a negative out in front? It flips it upside down. So you could graph it in your calculator if you wanted to, but it's just an upside down parabola. What do you think the domain is? How far left will that parabola go? Same, forever to the left and forever to the right. Positive infinity, or sorry, negative infinity to positive infinity. All right, letter C. What operation are we doing on letter C? Multiplication. We want to do f of x times g of x. What is f of x equal to? 4x squared minus 9 times. What is g of x equal to? 5x squared plus 3. What's the problem with how I have this written? It looks weird, doesn't it? What does it need? Parentheses. We are multiplying the entire functions together. You need parentheses because we're multiplying all of it. Okay? Both functions together. So we need to go ahead and distribute carefully. So we're going to distribute here. What is 4x squared times 5x squared? 20x to the 4th. Very good. What is 4x squared times 3? 12x squared. Very good. Distributing the negative 9. What is negative 9 times 5x squared? Negative 45x squared. Good. And last, negative 9 times positive 3? Negative 27. Very good. And we just need to, again, combine some like terms in the middle there. So we get 20x to the 4th. What is 12x squared minus 45x squared? negative 33 x's squared. Good. Minus 27. So there is our final answer. Does anyone know the shape of this graph? It is a W. When in doubt, graph it out. 20x to the fourth minus 33x minus 27. So if you didn't know what it looks like, you can graph it. This graph doesn't look super hot, but it's been shifted down 27. So I'm going to change my window. I'm going to go from negative 50 to positive 50, and you can see then a little better picture. Oh, I typed something in there. Insert squared. There we go. All right, that's better. All right, so this is the graph, and you can see it's a little W shape. Kind of cool. Again, how far to the left does this W shape go? Forever to the left and forever to the right. So that's domain, negative infinity to positive infinity, forever to the left and forever to the right. All right, last one. G of x. What can I replace G of x with? Whoops. G of x. Oh, changing the order here. G of x. What can I replace G of x with? 5x squared plus 3 on top. What do I get to replace f of x with? 4x squared minus 9. That's a great answer. That's totally a fine answer. In fact, most of the time you'd be done. But because I'm going to ask you about domain, what should we do to figure out domain? What's the domain here? What do I have to do? Double, yeah, the denominator can be factored, ladies and gentlemen. We can factor that denominator. What times what is 4x squared? 2x times 2x. Very good. What times what is negative 9? Positive 3 and negative 3. Very good. And we know denominators are not allowed to be 0. So each of these, 2x plus 3, is not allowed to be 0. And 2x minus 3 is not allowed to be 0. So what do we need to do to solve for x? How do I solve for x? Move the 3. I'm going to subtract the 3, so I get 2x equals negative 3. And then what do we need to do? Divide by 2, divide by 2. So we get x cannot equal negative 3 halves. What do we have to do over here? Add 3, so 2x cannot equal 3. And then again, divide by 2. X cannot equal positive 3 halves. That is domain. We had a denominator, so we could find domain pretty easily. All right. Your worksheet doesn't ask you to do that, just so you know. All right, questions on these ones? All right, here we go. This is example 2. Example 2. Given g of t equals t squared minus 7, and h of t equals 5t minus 2. What's different here? There's t's instead of x's, that's true. What else is different? Yeah, all all these are numbers instead of x's. Okay? This is going back to the notation that I had you copy down. You have to understand the notation. This is not g plus h times 4. It does not mean multiply by 4. It's the notation. If I go back to the notation page, we had, here's that notation they gave us, but this is what it really means. F of something plus g of something. So when I see this notation, I have to know that it really means g of 4 plus h of 4. And this is function notation, just like we did yesterday. What does g of 4 tell you to do? Yeah, replace the t, trade in the t, and plug in a 4. So we are replacing the t, and we're plugging in the 4. Plug in the 4. So what should I write? What does g of 4 mean? What should I write down? Not times 4. It's not multiply by 4. It does not mean that. It means plug in the 4.
4 to the power of 2.
There, 4 to the power of 2 minus 7. That's what that means. Then we have a giant plus sign. Now, what does h of 4 really mean? What does h of 4 tell you to do? Plug a 4 and go to the h function. And what are we plugging in? Replacing the t with a 4. So what should I write down? 5 times 4 minus 2. Very good. You'll notice I put in parentheses here. I did that because it's a good, safe thing to do. What is 4 squared minus 7? Nine. What is 5 times 4? 20 minus 2? 18. So what is 9 plus 18? 27. That's our answer, ladies and gentlemen. Done. We don't have to talk about domain on these because this is just a number answer instead of an answer with x's. All right, again, we have this crazy notation. G minus h of negative 2. What does it really mean? It means g of negative 2 minus h of negative 2. What does g of negative 2 tell you to do? Negative 2 to the power of 2 minus 7. Very good. That's the first thing. Then we have a giant subtraction sign, being very careful. What does h of negative 2 tell you to do? 5 times negative 2 minus 2. And again, I'm being very careful. I want to subtract all of that. So that's my second thing. I went ahead and put that in parentheses. The nice thing is, if you write it out like this, you can go directly to your calculator. All right, and that's what the easy thing to do here is. We can type it in exactly how we have it written, negative 2 squared minus 7, with all the parentheses, and subtract 5 times negative 2 minus 2. So I'm typing it all in just exactly how I have it written. And your calculator can do the math for you. So that's super nice. a good night. Okay. Questions on either of those? Okay. If you didn't want to use your calculator, then you'd simply evaluate the first thing and evaluate the second thing and then subtract them. All right. Okay. What does GH of -3 really mean? Or sorry, of 3 really mean? What does that notation? G of 3 times H of 3. That's what the notation really means. So what does G of 3 tell you to do? What should I write down? Good. 3 to the power of 2 minus 7. That's the first thing. And then we're going to multiply. What does H of 3 tell you to do? Five times 3 minus 2. And again, I'm putting that second thing in parentheses as well. And if you would use those parentheses and you can just type it in exactly how you have it written. So 3 squared minus 7. I did it again. Minus 7. And then 5 times 3 minus 2. So plugging in just exactly how we have it written, and we get 26. Why are we getting number answers instead of numbers with or answers with X's in them? Yeah, we don't have any X's here. They're telling you to plug in numbers. So. All right, last one. What does this notation mean? G over H of 1. What does that mean? G of 1 over H of 1. What should I write for G of 1? One squared minus 7. 1 squared minus 7. What should I write for H of 1? 5 times 1 minus 2. 5 times 1 minus 2. And then we can just simplify that. That's pretty easy. 1 squared is 1 minus 7. 1 minus 7 is -6. In the denominator, 5 times 1 is 5. 5 minus 2 is 3. And what's -6 over 3? -2. All right. Do you guys have any questions for me? Ready to use your calculators? It's really, really, really helpful. You guys have class practice 16 today. 16.
Like turning my
The tightest I remember every one time it's like 40.
No, I'm just like Your foot is big. Yeah, on the video it's so long.
Oh, thanks. About to end.